Hi, I'm Maria Copot, and me and my colleague Sara will be presenting our work on a community-centered workflow for morphological annotation. We can look at fieldwork as a collaboration between the researcher and the community, one that should be conducted ethically. Our work speaks to two aspects of the ethical nature of this interaction. The first is the need to see community members as collaborators rather than research subjects. And the second is to aim to give community members maximum agency over the process of fieldwork, as well as its output. Currently, several things are standing in the way of engaging communities more, but the ones that our work will address are the hurdles given by the use of software and practices around it. There is currently quite a high technical barrier that a user must clear to use software that exists, which is not a given in the community. And to perform all sorts of tasks at all sorts of levels, there is a need for linguistic training to do things such as applying morphological labels to a text, which is also not given for a community member. To increase community engagement, we wish to focus on improving annotation practices. Here is a basic example of how standard annotation practices currently operate today. We start with a sentence in the object language, here English, and we segment it into words and into morphemes. On the second tier, we then gloss the functional morphemes. Here, S is glossed as plural, representing the fact that S is what makes the word cats plural. This is perfectly adequate in a number of languages and contexts. However, it has diminished usefulness for understudied languages in particular. This is for two sets of reasons. The first are the theoretical issues that it brings. It forces researchers to commit early to an analysis of the system. So to gloss would have chased as conditional, perfective, and past, one needs to have already fully mapped out the English tense, mood, and aspect system to know what contrasts are important. It also forces researchers to assume that all languages work segmentally, which we know is a false assumption. So, for example, here, there is nothing in mice that explicitly marks it as plural, so we're forced to mark the whole form as mouse. By doing so, we miss out on the generalization that mouse, mice is a pattern that we find elsewhere in the language to pass from singular to plural. We also find it, for example, in louse, lice. And this generalization is not captured by this linear form of glossing. It also comes with practical issues. It makes suboptimal use of human time. Unless what we're trying to do is have a fully transcribed corpus, if what we want to do is analyze the system, then this is not going linearly through a corpus is not the best way of going about it. Also, it requires linguistic training. To know what perfective means, the annotator needs to have a strong background in linguistics. The hurdles brought by existing annotation practices for community engagement are compounded by the hurdles brought along by existing software. Which is challenging to use for both the linguist and the consultant. As mentioned, it requires intensive linguistic training, which is going to be a problem for the linguistically untrained consultant. And even for the experienced linguist, it's hard to annotate consistently. Human error will come at all sorts of places. Software also requires intrinsically non-trivial technological ability, and current software doesn't integrate well with non-proprietary software, which makes it hard to integrate all sorts of advances in natural language processing and computational linguistics that could really be of use in the process of annotation. We propose that community engagement in annotation processes can be improved by a workflow relying on two things. The first is a new theoretical framework, word and paradigm morphology, which will help us build a more intuitive annotation process in a software interface. The second is the integration of computational methods and machine learning into the workflow. This will be able to automate the initial steps of the analysis of a morphological system. It will suggest the most informative data points to annotate next, and it will automatically extend the annotation and the analysis to new data. So here's a quick primer on word and paradigm morphology. In this theory, an analysis of a system is the result of establishing parallel relationships of form and meaning between words of a language. Here is a word and paradigm representation of part of the English verbal system. In word and paradigm morphology, the word is the smallest unit, and it's not defined by the bits that compose it, by the morphemes and what they mean, but rather by its place in a system of contrasts. So here's an example. Syncing is not defined as being sync plus ing, but rather by its place in the system. So we note that the relationship between sync and syncing is parallel to that between ring and ringing and wink and winking, etc. So it's in contrasts with the words in the language on two axes. One is the cell, and one is the lexeme. Interesting to note that in this system then concepts like paradigm cell or lexeme are things that are emergent from having set up all these parallel contrasts. Once enough of these are established, we can then extract paradigm cells or lexeme groupings from this. So how does word and paradigm morphology translate into an annotation system? We saw that a word and paradigm system is the result of establishing parallel contrasts of form and meaning in the language that then end up giving us these two dimensions of the system, the cells and the lexemes. The task of the annotator in such a system would be based on deciding whether two items in context share a property of being in the same lexeme or in the same cell, or whether they don't. And from establishing parallel contrasts, we can build up the system. The first set of tasks for the annotator is deciding whether two given words belong to the same lexeme. Once lexeme groupings have been roughly established, we can work on the cell dimensions. So we present annotators with pairs of words belonging to different lexemes, and we ask them, are these in an analogous relationship? Is the relationship between sink and sung and ring and rung the same relationship? And this allows us to identify the cells that define the system. So here's the elevator pitch for what we're proposing. We're proposing a workflow for morphological analysis that starts from documentary corpora and then outputs a paradigmatic morphological analysis of the system. The initial steps of the analysis are automated thanks to computational methods. The annotator will then correct this initial analysis through the simple task of being asked whether two things are the same or different. This will thereby increase community engagement because the annotation task is much simpler than current practices. And this is integrated with a machine learning method known as active learning, which learns in real time from human input. This allows us to update the analysis after each annotation corrector, and also it directs the annotator's attention to the most informative data points for achieving a final analysis of the system.
So here's the workflow in a bit more detail. We start by obtaining a preliminary analysis of the morphological system that we're interested in. And so to do this, we make use of a computational model put forth by Jean et al. In 2020. And we scan through a corpus of text using a list of lexemes, and the model then identifies potential associated word forms for each lexeme, as well as how many paradigm cells are proposed to instantiate the morphological system and where these word forms fall within that system. And so if we look at the example, we see that we get something that's a good starting point, but we do have some errors we want to correct. So for example, the model incorrectly proposes the word heart to be an instance of the lexeme here, and we know that this should belong to a different lexeme. It also distinguishes heard and helped as if they belong to two separate paradigm cells, but we'll probably want to merge these to have them represent a single past tense paradigm cell. So we want to get a human involved. And what we've been working on is a software interface that allows a human to go in and make corrections to the model's predictions. And we want to do this in a way that is as intuitive as possible. So the way we do this is we take examples of the word forms that the model identifies in context from the corpus and present them in groups associated with each lexeme to the annotator. And the annotator's task is really straightforward. It's just to decide which of these are the same and which are different, which of these don't belong. So for the verbal lexeme here, we might think that the first two examples here are okay, but the third example we should exclude because problems of hearing and understanding is using a noun form. And in this fourth example, we see that heart word form that we're going to want to associate with a different lexeme altogether. And so as the annotator continues to provide input and make these sorts of corrections, the model on the back end is consistently updating its representation of the morphological system. And we want to do this in a way that is as efficient as possible. And so we make use of a technique called active learning. The way this works essentially is that the annotator is going to be presented with examples that are reshuffled in real time according to how the model will best be able to improve its representation of the morphological system, which is to say those examples that are most uncertain for the model are presented to the annotator first, allowing us to make the most of annotator time. And so if we want to make adjustments to the paradigm cell analysis, as Maria mentioned, it's going to be a very similar task, but rather than asking the annotator to decide which of these individual word forms are the same or different as associated with the given lexeme, we're instead saying, is this relationship between these, this pair of words the same as the relationship between this other pair of words? So we're using pairwise analogy here. But the process is essentially the same. We're excluding those that don't belong, and we're making use of active learning to make the most of annotator time. And we end up with something like this. So we see we have a paradigmatic analysis of the morphological system using unlabeled groupings of lexemes along the vertical axis and paradigm cells along the horizontal axis. And this can be used then for further linguistic research, as well as the development of materials that are beneficial directly to the native speakers of the language that we're working with. So in summary, we obtain a paradigmatic analysis of the morphological system as a whole. This consists of grouped unlabeled cells and lexemes that have been corrected by human annotators and are associated with examples of these words in context from our text building up our annotation of the corpus. So this combination of paradigms, concordances, and texts can be used not only for further linguistic research, but also the development of community resources and pedagogical materials for the native speakers of the languages themselves. And so we were interested in seeing how this might play out in a realistic fieldwork setting. And one of our team members has been working with speakers of Guaterero. This is a linguistic isolate spoken in Ecuador with approximately 1,200 to 3,000 speakers. And so as part of this language documentation project, he asked two of the consultants he's been working with to help with an experiment of sorts. Neither has taken a course in linguistics, and so they sat down together and he explained the task using Spanish verbal paradigms as examples and asked them to annotate as many items as possible, both lexemes and paradigm cells, within a single hour. And then afterwards collected some qualitative feedback. And so the annotators said they thought it was a really understandable task, it was interesting, and there was actually a lot of agreement between the two annotators in the ways that they made their decisions. In fact, they said that it might even be more interesting to do this task as a group with other speakers together. And so we think that this is a proof of concept here that our proposed workflow has the potential to increase our ability to engage the native speakers of the languages that we're working with and thereby increase their agency in the language documentation projects that we're doing. So in the future, we hope to improve the ways that this model is making its suggestions, and part of that then involves giving annotators a way to directly provide examples of word forms that they know to exist within the language that the model may have missed. So right now, annotators are only able to confirm or reject examples that are proposed by the model. In the future, we hope that annotators will be able to provide this input more directly and have this propagate throughout the way that the model is making its suggested annotations. In conclusion, we are proposing a workflow for morphological annotation that is grounded in word and paradigm morphology. And in particular, we're trying to do this in a way that is intuitive. So relying on this decision-making of same or different of word forms in context, which allows native speakers to contribute their expertise as native speakers to the annotation process and increase their participation and agency in our language documentation projects. From the theoretical standpoint, it also allows us to defer these decisions about segmentation and labeling, which can be quite complicated at initial stages of a morphological analysis, and instead obtain a paradigmatic analysis of the morphological system as a whole. We're also focusing on making this modular, which is to say we want both to be able to interface with existing software solutions that people are using for these kinds of projects, but also we want to be able to keep up with the rapid pace with which computational linguistics is developing technologies that could be beneficial for these projects. Finally, the output that we obtain is useful both for further linguistic research as well as the development of community resources and pedagogical materials, and this is something that we're really trying to focus on as we develop the software and the workflow itself. So I'd like to thank our collaborators in Ecuador, and also thanks to all of you for your attention.